So I've had some questions about problem number 9 and 10 on section 4.6, which is factoring trinomials. And so I just want to do an example of the type of problem you're going to run into that uses factoring with substitution. So this problem, your gut might tell you that the first thing to do would be to multiply out 4x plus 1 squared. And yet that would not be the best place to start. An easier approach is going to use substitution. And I'm going to pick just any variable, but I'm not going to pick x or y. I'm, in this case, going to pick u, something I normally wouldn't use. And I'm going to let u equal that expression that's in parentheses, 4x plus 1. So now I'm going to substitute this u every time I see 4x plus 1. So the first place I see it is right here in that first term. So that is going to become u squared. Then I see it again in this 4x plus 1 right there in my middle term. So that just becomes a regular plain old u. And then I have the minus 2. Now that looks like a super easy problem for me to factor. And so that's what I'm going to do. That one is going to be u minus 2 u plus 1. All right. So now what I'm going to do is factor back in this 4x plus 1 everywhere where I have a u. So that is going to be, let me just put it in pink so you can very easily see my substitution. 4x plus 1, that is for that u. And then I've still got this minus 2. Then I've got my 4x plus 1 again for that u, and then I have my plus 1. So now I just simplify inside of those parentheses. So that becomes 4x minus 1, 4x plus 2. Okay, normally I would say you're done, but you really need to take 5 seconds and look at that final problem. Look at that final factoring. Can you take out a greatest common factor from either binomial? The answer is yes, okay? This second binomial has a greatest common factor of 2. So I'm going to take that out first. So I'm going to take out the 2, so then I'm left with 2x plus 1. And then right after it, I'm just going to put this 4x minus 1. That is your final answer. Now that is factored fully. Not so bad. Now, there's also going to be problems that look like this. T to the 6 minus 14t cubed plus 40. Now, some of you have no problem with those exponents that are not a 2, and you can just go to town. Other people look at that and they're like, I'm lost. So you can use substitution for this problem too, because let's just go ahead and break down those exponents a little bit. So here's what I mean. I really want this 6 to be an exponent of a 2. So if I divide that 6 by 2, that'll give me a 3. So this can become t cubed raised to the second power. So you can remember from your properties of exponents that when you have an exponent raised to a power, you multiply that 3 times 2, that gets you back to that 6. So then we've got minus 14t cubed plus 40. All right, so now I have a t cubed that's in 2 parts of my expression. So I'm going to let u, okay, I'm going to do my substitution, let u equal t cubed. So that's going to be u squared okay, minus 14u plus, plus 40. All right, so now that's a little bit easier for our brain to look at. It's more similar to the types of problems you were doing earlier in this section. So I can just factor that. So that's going to be u minus 10, u minus 4. Now I go ahead, I just substitute back for that u, that t cubed. And so that is going to give me t cubed minus 10, t cubed minus 4. Done. So hopefully this helps you with those last two problems.